Okay, hello guys, welcome to my stream. I know there's no one watching me, but I'm just gonna explain what I'm doing. Why did I stream? Okay, so basically I'm just gonna stream of about me. You guys are gonna see me study about cybersecurity, but the point of the stream today is of me pushing the Portswigger Academy. So what is Portswigger Academy? Basically, me as a cybersecurity student, I want to learn about web security. Portswigger provides us with a great academy to learn about all of the good ones, like most most used maybe. I don't know how to explain it because English not is not my first language, but yeah, basically web security. That simple. So what am I gonna do in the stream? Number one, I'm gonna write notes. So for the notes, I won't show it to stream, but if you see here below, I'm opening a cherry tree. That's where I'm gonna write my notes, and I will possibly explain it to you guys if I can, and probably improve my English because I know most of you guys have better accent than me. And yeah, that's basically it, and probably have fun. So let's get started. So I did some of the Cysec vulnerabilities and also the LFI, the path traversal. But this was like from 2 years ago, and this was like from some months ago. So I stopped, but I'm gonna do it now because I'm on my holidays and I'm bored. So I'm just gonna do this now. Okay, let's resume. Okay, let me explain to you the ones that I completed. So path traversal is basically LFI where we can access like um how do I explain it? Basically access a file that is not permitted. That's simple. Access control is basically like broken access control, like accessing admin systems and stuff. Yeah, authentication is basically like imagine a login page. Imagine if you can brute force the login or you can bypass the two factors when logging in. That's an authentication vulnerability. So yeah, that's about it. Let's start. So I'm gonna start with SSRF. I'm gonna read and possibly explain it to you guys. Okay, so basically I have some context because I do CTFs, but I'm gonna explain it as simple as possible that I can. So SSRF just means like we can access internal services, like we can make the server access it. So we can change the logic of the server. It's very cool. As you can see, here it says server side request forgery. Server side, so it's from the server side, not from our side. Okay, let's continue. Yeah, so basically in this case, this is a example of SSRF attack. So there's an application that shows us the stocks on stores. So here, as you can see, the stock API, we can provide a URL to give to the stock API, and it will access it. Because let's imagine it. Let's create pane. So this is us. We want to see, uh, we want to see the stocks from let's say company A, and we want to see the stocks from company B. So we'll provide the URL of the company B and company A. But what if the machine, so we, wait. So we give the URL to a machine, right? Then this machine will access the A and B. What if we give it the admin, the slash admin? So the administrative part of the website of the machine. Then it will access itself and access the slash admin. Yeah, that's about it. That is SSRF. See here? It will go to localhost, then access the slash admin, and then give it back to the user. So this is a very bad problem. Oh yeah, I forgot to take notes. Wait, let me take notes. Let me copy this part. Why is it? Never mind, let me just write it. Yeah, this part is very interesting because it says the the check. Maybe when we log into the account, it was like not service sided, it was client sided. So it'll check on the client side, but it won't check on the server side. Probably. If I'm wrong, you can just say it. Oh yeah, this is where the company provides too much trust to the server. See, trust relationships. So this is where the company uh do a no trust the machine too much. Okay, basic SSRF against local server. The Slav has stock check feature which fetches the data from internal system. To solve the lab, change the stock check URL to access the admin interface at localhost admin. Okay, let's save this. Let me open my notepad. Okay, we need to delete the user Carlos. Let's note that as well. Delete user Carlos. Okay, let's try accessing the lab. Wait, what? Okay, stock check feature. Where's the stock check feature? My account. Hmm. Oh, interesting. So we can check the stock of the products. Let's open it up on Burp. Wait, wrong. Let's try intercepting. Oh yeah, it's the same. So what if we put it on a repeater? Let's check. Okay, it will provide the units probably. Then let us try the accessing the localhost. CTP localhost admin. Oh yeah, it renders. So what if we check stock then http localhost admin. Then we forward and let's delete Carlos, isn't it? Carlos. Hmm. What if we ask it to access this part? Can we? Hmm. What's wrong? Oh, maybe localhost. Hmm. What's wrong? I don't understand how this doesn't work. Isn't this working? Wait, what? What's happening? Oh, it's solved. Okay, we did it. Okay, nice. I thought there was something wrong with the lab, but it was my skill issue. Okay. Okay, so we finished the challenge. Nice, that was fun. Wait, why did it say skip the lab? Okay, I solved it now. Okay, let's continue. SRF attacks against other back-end systems. Okay. In some cases, the application server is unable to interact with back-end systems that are not directly reachable by users. These systems often have non-routable private IP addresses. The back-end systems are normally protected by the network topology, so they often have a weaker security posture. In many cases, internal backend system contains sensitive functionality that can be accessed without authentication by anyone who is able to interact with the system. So this means if we get an SSR vulnerability, you could access this backend system without any checks. In the previous example, imagine there is an administrative interface at the backend URL. Oh, so it's a LAN. Okay. An attacker can submit the following request to exploit the SSR vulnerability and access the interface. So basically, it's similarly like this. Imagine this is the local place of the company. There are like a lot of computers, right, and servers. And imagine this is the product company. I know the product server or the computer, anything you want to say. And this is the admin functionality. Because it is local, from this IP address, you can access the admin IP address through SSRF. Yeah, insane. Okay, another lab. This lab has a stock feature which fetches data from internal systems. To solve that, use a stock to scan the internal for the admin interface on port 8080. Then use it to delete user Carlos. So good thing that I didn't close the burp sheet. So wait, no. So I need to do it again. Okay, let's solve it then. It's taking a while. Yeah, let's bring it here to my portswigger. Few details. It's a bit laggy. No, it's a lot lag. It's very laggy. Let's intercept the stock. So it's the same. But now, let's check this out. If I try to access localhost admin, it probably won't work because see, internal server error. What if we we could do a it has a session. Is it different every time? Well, it's the same. Okay. Where's the intruder? Then we can try to brute force the X at simple list numbers from 0 to 256. No, from 1. No. I was wrong. Okay. Start attack. Yeah. Ooh? No. Am I wrong? I didn't need to create a Python script, right? I'm so lazy. Okay, let's wait until it finishes. Yeah, is it not working? Am I cooked? Okay, let's wait. Is the attack working though? 1686. Oh, on port 8080, I didn't see that. Okay, so I have to redo the attack. Oh, this is so annoying. I still have it on intruder. 8080. Let's try. Yeah, we found the. It's probably 0.1. I forgot what that meant. Website, I forgot. Okay, so we know that it's 1. So we can just repeat. Let's try accessing it. Missing parameter. What if we give it a random parameter? Username. Carlos. So it's not working. What's wrong? Some is the check function is that. Oh, I don't think this is the. Yeah, I don't think this is the internal system. Let's continue the burp for now. Let's try. This has more line. That's interesting. Oh, we found it. It's on 10. So I was actually wrong. Okay, my bad. So let's confirm that. It's on 10. This should give us the. This should actually work now. Okay, nice. Okay, this was actually easy, but I. Let's stop the intruder. Discard. Let's just solve it now. Let's copy from a Peter. Because I forgot the API that deletes the user. Yeah, it's not solved yet. Let's see. Oh, it's delete. Okay. Delete username Carlos. I remember that. Let's try sending it. Huh? Illegal? Is it the username? Illegal. Oh no. Username. Calls Carlos. What? What was the problem before? I don't understand. Okay, so we finished the challenge. Okay. Oh wait. Okay, it's solved now. So yeah, that is basically SSRF. We could access the internal services, like even on the different servers, like on local servers. I know a lot of company uses more than one server. You could from server A, you could access server B. From server B, you could access server C. Yeah, it's basically like that. Okay, so moving on. Oh yeah, I haven't even taken notes. I should take notes more. Okay, nice. So moving on. Wait. Hmm. That's like even on the different servers. Test. Okay. So continuing on, we are going to start to learn about file upload vulnerabilities. File upload vulnerabilities are when a web server allows users to upload files to its file system without sufficiently validating things like their name, type, contents, or size. Failing to properly enforce restrictions on this could mean that even a basic image upload function can be used to upload arbitrarily and potentially dangerous files instead. This could even include server-side script files that enable remote code execution or RCE. In some cases, the act of uploading the file is in itself enough to cause damage. Other attacks may involve a follow-up HTTP request for the file, typically trigger its execution by the server. Okay. Okay, let me copy that for the notes. Let me take my notes first. Okay, how do file vulnerabilities arise? Given the fairly obvious dangers, it's rare for websites in the wild to have no restriction whatsoever on the files on which files users are allowed to upload. More commonly, developers implement what they believe to be robust validation that is inherently flawed or can be easily bypassed. For example, they may attempt to blacklist dangerous file types but fail to account for parsing discrepancies when checking the file extensions. As with blacklist, it's also easy to accidentally omit more obscure file types that may be still dangerous. And to check the file type by verifying properties using tools like pursuit or repeated. Ultimately, even robust validation measures may be applied inconsistently across a number of hosts and directories from that form the website, resulting in discrepancies that can be exploited. Okay. Wait. Let me pause a bit. Yeah. So this explains the file performability. So in this example, imagine you have like a image uploading website. Like imagine you could upload an image for your profile, but instead of an image, you upload a PHP file that is a server-side scripts like PHP. And here, in this example, in the script that you provided to the server, it will access a file that it shouldn't have. And in this part, it created an RCE where you can access the server, like the CLI of the server. Okay, remote code execution via web shell upload. This lab contains a vulnerable image upload function. It doesn't perform any validation on the files users upload before storing them on the server's file system. To solve the lab, upload a basic PHP web shell and use it to exfiltrate contents of. Okay, let's save this. Submit the secret using the button provided in the lab banner. Okay, so it's basically a flag. You can log in the account. Okay, winner Peter. Let's remember that. Let's try solving it now. Oh. I was a bit shocked about the picture. For the first time. Okay. So where's the file upload? Let's try Wiener Peter, right? Am I wrong? Oh, okay. Oh, see. It's basically the same as what I explained. It's a profile picture upload. So let's try uploading a save file first. Wait, you guys didn't see anything, okay? So let me try to upload a picture of Patrick. So as you can see, the avatars patrick.png is uploaded. So if I try to access the avatars patrick.png, what? Huh? Okay, I don't understand anymore. I know nothing about notifications. Patrick.png. What? Am I tripping? Huh? What? Wait, am I tripping? Oh no, I was tripping. Because I haven't uploaded yet. Okay, I understand now. See? After we uploaded the image, it will load. So it will store the image at the avatars folder and we can access it and it will load the image for us. But what if we uploaded a PHP file that contained a shell? Let's try. So wait one sec. So there's this famous website called Graph Shells that could help us. Oh wait, not. Oh yeah, it's called Graph Shells, and this is a famous website to help us create a RCE. So here is an example. Let's take the small. Or I think a better example would be from here. It's basically the same, but it's just calling the system. Let's use this one. Let's try creating the application. No, the code, I mean. Wait, why am I opening the photos? Wait, let me create a temporary directory. Yeah, it should be fine. Okay, let's create the, what should we call it? Shell.php. Yeah, Now, what if we upload it to the website? Let's try. Back to my account. Let's open the image on a new tab. So, in our code, let's check it out again. It will ask for a command parameter that we can give it by doing this command. Then it will put it on a system, then echo the output. Let's try doing a who am I? Carlos. So the goal is for us to access to get the contents of the file of home Carlos secret. Let's try viewing it. Cat. What is this? Okay, so this is basically the secret. Let's try submitting a solution. Incorrect. Huh? Why is it incorrect? I think the challenge is broken now. It's the same. Why is it not working? I don't understand. Is this like base 64? Magic. Oh, it's basically the key, right? Why is it not taking the key? Am I wrong? Let's try checking the solution. Yeah, it's the same, right? Yeah, it's broken, right? It's basically the same. What am I doing wrong? Okay, so let's just try using the viewing. I don't understand how this doesn't work. It's basically the same, right? I don't understand. Wait. What's different? Okay, let's try doing it again. Oh, I didn't see that. There was two outputs. Yeah, you can see the NKU4. Oh, I was so stupid. I didn't. Okay, okay. So I was correct, but I didn't know that it will output 2 times. Okay, that's good to know. Okay, let's continue. Exploiting flawed validation of file uploads. Wait, let me put it on an example. Let's put this on the example for 9 notes. Should be fine. Okay. Exploiting flawed validation of file uploads. In the wild, it's unlikely that you'll find a website that has no protections against file uploads. Wait. In the wild, it's unlikely. But just because defenses are in place, that doesn't mean that they are robust. You can sometimes still exploit flaws in these mechanisms to obtain a web shell for remote code execution. Flawed file type validation. When submitting HTML forms, the browser typically sends the provided post request with the contents applications X form you encoded. This is fine for sending a simple text like your name and address. However, it isn't suitable for sending large amounts of binary data, such as an entire image or a PDF document. In this case, the content type multipart form data is preferred. Consider a form of containing fields for uploading an image. Provide a description of it and entering your username. Submitting such form might result in a request that looks something like this. Wait, what? Form containing fields for an image. Yeah, content description image. Yep. Yeah. As you can see, the message body is split into separate parts for each form inputs, each parts containing content disposition header. So this is the content disposition, right? Oh yeah, here. So this is probably the content disposition header. Yeah, it's probably the name that provides the example. Oh, we can have multiple like datas. Okay. Yeah, content type. Oh, this is the example. Okay, so we are gonna bypass the MIME types. Okay. So let's try taking this, putting it on notes. This could be helpful maybe. Also take this one. Okay, let's continue. This app contains vulnerable image functions. It attempts to prevent users from reading unexpected file types, but relies checking user control input verify the software app. Upload a basic PHP website to execute and contents. Okay. Okay, let's try. This is interesting. I think we have to get back to go back to burp sheet to solve this one probably. Let's remove this from intruder. Remove the intruder. Okay. Huh? I solved this one? Oh yeah, this is the one from before. Okay. Okay. So this probably has something to do with our count. Smear again, right? Oh yeah. So first let's try uploading a picture. Let me open another. Let's try opening a picture. Here, let me upload the picture of Patrick again. Upload. What? Huh? What's happening? What? Yo. Okay. So it works. But what if we upload the shop HP that we still have? This one. Let us try. Okay, so only image JPEGs and image PNG are allowed. But so they trust the header, right? So look at this. What if we upload shell.php, then we change the content type to image.png, image/png. So the server will see the content type and it will trust it, and it will say this is an image. What will happen? Boom. Then you can try accessing it. Match a new tab. Then can run command. So where are the files that we have to access? I forgot. Oh, let's just access it immediately because I don't want to stay here any longer. Cat. Yeah, we finished the challenge, but I have to look out for the duplicates. Yeah, we solved the challenge. Nice. That was easy. That duplicate, the duplicate output was very annoying. I don't understand why it shows 2 times. Yeah, that was fast and that was fun. So let me take the notes. I'm probably just gonna screenshot this part. That's too small. 700, 800. Okay. Okay, that's the basics of file upload. Nice. Very cool. So now we are gonna go into command injections. So let me create a subnode for it. copy this part. OS command injections is also known as shell injection. It allows an attacker to execute operating system commands on the server that is running an application. Oh, so this is similar to the case about file upload vulnerabilities that we did. This should be a OS command injection vulnerability. It's the same probably. And typically, fully compromised application and its data. Often, an attacker can leverage an OS command injection vulnerability to compromise other parts of the hosting infrastructure and exploit the trust relationships to pivot the attack to other systems within the organizations. Okay. And why is that? Because having a command injections makes us have a that explains basically we have access to the local servers, so we have access to the local services as well. Probably. Useful commands. After identify OS command injection from it is useful to execute some initial commands to obtain information about the system. Below is the summary of some commands that are useful on Linux and Windows platforms. QMI basically just tells us the user we are on. Uname or var just gives us the version of the OS, like what operating system is using. Like in Linux, maybe it tells us we are using Ubuntu or using CentOS, I don't know. The network configuration, fconfig is basically ipconfig. If you know a little thing of two about networks, if you ever seen or checked your local IP network, this is the command for it. Network connection netstat is basically just seeing all the network connections that are being processed, and PS is basically our task list. It's basically like task manager. You can see all the processes that are running. Yeah. Injecting OS commands. In this example, a shopping application lets the user view whether an item is in stock. Oh no. Let me read it again. In this example, a shopping application lets the user view whether an application is in stock in a particular store. This information is accessed via URL. So we can see the website. It takes us to a stock status API, and we can give it two parameters, the product ID and store ID. To provide the stock information, the application must query various legacy system for historical reasons. The functionality is implemented by calling out a shell command with the product and store ID arguments. This command outputs the stock for the specified item, which is returned to the user. So this is the shell command probably. So I think in my head, stock report.pl is like basically a binary or a shell command from on the server, and we can provide two parameters. That is first the product ID here and the store ID here. But this is when it became the shell command. So let's continue. The application implements no defenses against OS command injections, so an attacker can submit the following input to execute an ability command. So basically, let me provide you an example. Let's save it here. Then let's copy. Oh no, there's an example below. Yeah. Example. What if we provided on the 29? If you can see, we can provide it like this, right? But what if we put this behind the 29? Then the command that the server would run is this. It will use the functionality like the binary that is used to get the stocks and also do the echo. So this is a problem because what if we access like internal system using this part of the command? Yeah, the command causes the supplied string to be echoed in the output. This is a useful way to test for some types of OS command injection. Yeah, this is the command separator. We can also use like this. I don't know what it's called on English because let me just search up what is called. Oh, semicolon. Okay. Yeah, because the 29 here. Oh, so in this part, he put the echo on this part. Yeah, and he also put the and comment here. So in the URL it should look like this. Yeah, probably. Yeah, here. Because there are no inputs to the stock report.pl, so it will return an error because it doesn't know where to look for the stocks. And the injected echo here will run because it's the only valid shell command. And the 29 is like there's no command called 29. That's basically why it gives an error. Placing the additional command separator after the injected command is useful because it separates the injected command from wherever follows the injection point. This reduces the chance from. Okay, let me just copy this example. Yeah. Lab OS command injection simple case. This lab contains an OS command injection vulnerability in the product stock checker. Okay. Let's keep that in mind. Product stock checker. That's basically what we are using, what we were using for like the last 1 hour. The application executes a shell command containing user supplied product and store IDs and returns the output from the command in its response. To solve the lab, execute my command to determine the name of the current user. Okay, let's try solving it. I think we are gonna need our burp sheet again. So let's open our burp and wait for the. Okay, loaded. Nice. Let's solve it now. This should be easy. Okay, let's intercept the request first. Oh wait, no. Okay, we have to wait again. Let's check the stock, intercept the request, return. Yeah, it should returns. It's a return number. What if in the store ID I put a semicolon, then I say, who am I? Done. We solved the challenge. Easy as that. Or you could this is the easiest way. I'm just gonna let it stay like that. Okay. Yeah. Nice. We solved the challenge. And that's it. That is OS command injection. Pretty interesting. Nice. So we are on our last part of the server-side vulnerabilities. Let us speedrun this because I'm getting hungry and tired, man. I'm so tired. Let me drink first. Okay, what is SQL injections? SQL injection is a web security vulnerability that allows an attacker to interfere with queries that an application makes to its database. So basically, any applications that uses a database will have a query to access the database. So we can interfere with that. That's basically the vulnerability. This can allow an attacker to view that data that they are not normally able to retrieve. This might include data that belongs to other users or any other data that the application can access. In many cases, an attacker can modify or delete this data, causing persistent changes to the application's content behavior. Yeah, imagine if he removes the admin's account, so there is no way for the admin to access the admin dashboard, right? In some situations, an attacker can escalate SQL injection attacks to compromise the underlying server or other backend infrastructures. It can also enable them to perform denials of service attacks. Yeah. So I have little information about this, but I know a bit or two. There are some cases which SQL can lead into file write or file read vulnerabilities. It depends on the privilege we were given or we have when we did the SQLE. And also about the DDoS, the denial of service attacks. I know a technique called SQL pool. I forgot what it's called, but it's close to that. A good friend of mine explained it to me. But yeah, that's about it. Let me copy that. I need to take more notes. Okay, let's continue. How to detect SQL injection vulnerabilities. You can detect SQL injection manually using systematic set of tests against every entry point in the application. To do this, you will typically submit a single quote character and look for errors or anomalies. Some SQL specific syntaxes that have led to the base to enter a different value and look for systematic differences on application response. Boolean conditions such as or 1 equals to 1 and or 1 equals to 2 and look for differences in the application's responses. Payloads designed to trigger time delays when executed within the SQL query and look for differences in the time taken to respond. OAST payloads designed to trigger an out-of-bound network interaction when executed within an SQL query and monitor any resulting interactions. Alternatively, you can find the majority of SQL injection vulnerabilities quickly and reliably using Barb Scanner. Okay, I need to drink. Okay. Imagine imagine a shopping application that displays products in a different categories. In different categories, okay. When the user clicks on the gifts category, their browser requests URLs. Okay, so we can we could like filter the products by categories. This causes the applications to make an SQL query to retrieve the details and relevant products from the database. So this is an example of an SQL query. It will select everything from the products table where the category is gifts and it's release 1. Okay, simple. The SQL query asks the database to return all the details C and from the products table and the category is gift and the release is 1. The restriction release 1 is being used to hide the products that are no release. Okay, so if we ever had a chance to see the 0, we could see the products that are not released. So it's basically internal data, right? Private data. We could assume unreleased products is 0. Let's continue. The application doesn't implement any defenses against SQL attacks. This means an attacker can construct the following attack. So it comments, yeah, this is probably just a check. This result in SQL query. Yeah, so it comments the release part, so we can view all the products that has the gifts category, even the unreleased one, we can view all of them. Yeah, this means that the rest of the query is interpreted as a comment, effectively removing it. Yeah. In this example, this means the query no longer includes unreleased one. As a result, all the products are displayed including those that are not released. Yeah, the same as I explained it. Nice. You can use a similar tag to cost application to display all the products in any category, including categories that they don't know about. Yeah, so gifts or 1 = 1. So if it checks like another category, maybe it's called drinks, then it'll check if it's called gifts or 1 = 1. So it is always true. So it will just show all of them. Query returns all the item where category is gifts and 1 is equal to 1. It is always true and the query returns all items. Interesting. So now we are given a challenge. SQL injection vulnerability where clause allowing retrieval or hidden data. This lab contains an SQL injection vulnerability in the products category filter. Where the user selects a category, the application carries out the physical following. Let's save it in my notes. Solve the lab, perform SQL injection, time cost application. Okay, let's try doing it. So let's try to understand it more. It will select from products where the category is gifts. Well, basically the same as the example, but I think we should access it in our burp sheet. Let's remove the intruder and let us wait for the application to load. Huh? What is happening? Am I tripping? Then why is it not working over HTTPS? Okay, it's broken now. Let me open the browser again. Yeah, this is so annoying. Okay, now it works. Nice. Okay, let's try. So this is probably the category filter. Let's try intercepting it. Okay, so it's from parameter. Let's try plugging on repeater. Yeah, so basically in this case, it's probably doing this. Accessories. Wait. Yeah, my bad. Okay. Now we know that it's using the single brackets, so I don't know what's called scope brackets, right? Yeah. We could just do that, then do or 1 = 1. So we could submit this, then yeah. No, we can just do this and it's solved. So we just need to comment the release one. So because the goal of the challenge is to display unreleased products, so this does that. Okay, let's try. Then do this. Maybe you can just filter to all. Never mind. So we do need the we want to find the unreleased product as fast as possible because we don't know which category has the unreleased product. So we can just do the R1 equals 1. So all the categories will show up. Then we solve the challenge. Nice. Easy. Cool. Let's check. Yeah, solve. Let's continue. Now, subverting the application logic. Imagine an application that lets users log in with a username and password. If a user submits the username winner and the password blue cheese, the application checks the credentials by performing the SQL query. Select everything from users where username is winner and password is blue cheese. This is the basics of SQL. And when you start learning on developing web applications, this is one of the most basic SQLs that you will use to find the username and password of a user. If the query returns the details of the user, the login is successful, otherwise it's rejected. You can imagine it like if there is no if you find someone called winner and the password is wrong, then it won't return anything. But if the password is correct, then a a column will return to us, so it will be successful. In this case, an attacker can log in as any user without the need of password. They can do this using the SQL command sequence command to remove the password check where clause of the query. For example, submitting the username, administrator, and a blank password results in the following query. See, in this case, it will select all from the table users where the username is administrator. Then this single bracket will close this bracket. Then it will comment everything behind, so it won't even check the password. It only check this part. Okay, this is the only query that the application will do. This query returns user whose username is administrator and successfully locks the attacker into that user. Okay, let's continue. Okay, so I don't know how I solved this before, maybe some years ago, but I'm just gonna resolve it. This lab contains a SQL injection vulnerability in the login functions. Okay, login function. We can use that as a reminder. To solve the lab, perform a SQL injection attack that logs into the application as the administrator user. So let's try solving it. So we can imagine the application using the same query, like select everyone from the users table where the username is equals what we give and administrator. In this case, what if we and the password equals the pass, okay? But if we put a single bracket here, then this part will close, then we will comment everything behind, then so we'll only check the username. And finding the username is gonna always return true because I know the administrator account is called administrator and it will it's already there. So yeah, I don't know how to explain it, but yeah, let's just put yeah, done. We solved the lab. As simple as that. I'm sorry if I can't explain it, if my explanations are bad because I don't know how to explain it. Yeah, that's it for SQL injections. Then we successfully finished the server-side vulnerabilities. Nice. Yeah. Yeah, that's it for today's stream. Thank you guys so much for viewing this stream. I know there's probably like nobody watching, but thank you.